Hello everyone and welcome back to 30 Days of Java. It's day 6 now and today we'll be looking at bitwise operators and operator precedence in Java. Our agenda for this video would be to understand about bitwise operator, assignment operator, and then look at their precedence order and associativity. We'll also be discussing about the comments and short-circuiting behavior of Java. As always, we'll put all of these topics in practice using IntelliJ. So let's begin. Bitwise operator performs operations on individual bits of integers. These operators work directly with the binary representation of data. It includes operators like AND, OR, XOR, NOT, left shift, right shift, unsigned right shift. Let's take an example to better understand the bitwise operators. Suppose you have two values, 2 and 9. Now, if you apply a bitwise OR operator on it, which compares each bit of two integers and produces a new integer, where each bit in the result is set to 1 if at least one of the corresponding bits in the operands is 1. It would first convert the numbers into their binary representation. For 2, it's 0010, and for 9, it is 1001. It would then apply OR operator on every bit of the number one by one. It starts with least significant bit, which is calculated to 1 as we have a 1 here in the binary representation of 9. Then it would move on to the next bit, which again comes out as 1. Now on the third bit, it sees that both inputs are 0, so it would give back 0 now and so on. Finally, we have the value 1011 as the result, which represents 11 in integer form. The truth table for bitwise OR operator is same as a simple OR operator, and same scenario is true for AND and NOT operator. For the remaining operators, we'll discuss them later in the video when we are implementing these topics in IntelliJ. The assignment operator is used to assign a value to a variable. It's a binary operator that takes the value on the right and assigns it to the variable on the left. The variable on the left must be a valid variable name, and the value on the right can be a constant, variable, or the result of an expression. Operator precedence defines the order in which different types of operands are evaluated. Higher precedence operators are evaluated before lower precedence operators, whereas associativity defines the order in which the operators of the same precedence are evaluated. As a basic rule of thumb, arithmetic operators always have the highest precedence, which is followed by relational operators, and finally, logical operators have the least precedence. For learning more about the specific operator precedence, you can check out the following link, which talks about the precedence and associativity of different operators in Java. I'll paste the link in the video description below. Now let's jump on IntelliJ to try out all the stuff that we just talked about. Let's first start with defining the bitwise operators in Java. In this example, we are using two integer variables, a and b, with the value 5 and 3 respectively. The binary representation of 5 is 0101, whereas the binary representation for 3 is 0011. In the first bitwise operation, at line number 7, we are using bitwise AND operator. Now the bitwise AND operator sets the bit to 1 only if both corresponding bits are 1. In the line number 11, we are using bitwise OR operator, where the result is set to 1 if at least one of the corresponding bits is 1. In the next bitwise XOR operator at line number 15, the result is 1 if the corresponding bits are different. For the bitwise NOT operator, it flips the bit, changing 1s to 0s and vice versa. At line number 23, we are using left shift operator, which shifts the bit to the left by a specified number of positions. In our case, we're shifting the bits by 1. That is why the output is 10. In the next operation, at line number 27, we are using right shift operator, which shifts the bit to the right by a specified number of position. The signed bit is filled for signed integers. And finally, we have the unsigned right shift operator. This operator is similar to right shift operator, but it fills the leftmost bit with zeros, even for signed integers. Now that we are clear with the bitwise operators, let's discuss about the operator precedence and associativity in Java. In this example, we have 3 variables a, b, and c, whose values are 10, 5, and 2. In the first example, we are setting the result 1 to a plus b asterisk c. Now multiplication has a higher precedence than addition. That is why b asterisk c is evaluated first and then added to a. So the result 1 should be 20. That is 10 plus 5 asterisk 2. Then it becomes 10 plus 10 and then 20. In the second example, we are setting the result 2 variable to a slash b asterisk c. Now division and multiplication have the same precedence in Java, so they would be calculated from left to right as per their associativity. So a slash b is evaluated first and then multiplied by c, so the final result becomes 4. In the third example, we are using the mixed operators, where we are setting the result 3 variable to a plus b slash c. Now division has a higher precedence than addition, so that would be calculated first. So the result 3 would become 12. Finally, in example number 4, we are using logical, relational, and arithmetic operators all at once in an expression. And then we are setting the result of that expression to variable result 4. So here, parentheses have the highest precedence, followed by the relational operator and finally logical operator. That is why when compiler evaluates the expression, 2 plus 3 is evaluated first, which becomes 5. Now the expression becomes 5 greater than 4 and 5 smaller than 7. Now we will be calculating the relational operators, so we go from left to right. Now 5 is already greater than 4, so that is why it is calculated as true, and the expression becomes true and 5 smaller than 7. Then 5 smaller than 7 is evaluated, which also comes out as true. Now the expression becomes true and true, and finally true, as we already know that for AND operator, both the inputs have to be true for the result to be true. Let's run this program and see if we were correct or not. Here you can see all the results that are there in console are same as the result that we expected. Now before ending this video, I would also like to discuss about the difference between assignment operator and equal to operator, which is a really important question from the perspective of interview. So in Java, we have 2 operators, equal to and then equal to equal to. The first operator represents the assignment operator, which just assigns the value on the right hand side to the variable on the left hand side. Then we have another operator that is equal to equal to. Now this is a relational operator that checks that both the values on its left hand side and right hand side are same or not. Coming back to the slide, let's now talk about comments. Comments are used to add explanatory notes or annotations within the source code. Comments are ignored by the compiler and have no impact on the execution of the program. They are meant for human readers, including developers who might be working on the code or reviewing it. Java supports 3 types of comments: single line, multi-line, and documentation comments. We'll see all of them in action while implementing them in IntelliJ. Short-circuiting is a behavior exhibited by logical operators in Java and many other programming languages. Short-circuiting means that the second operand of the logical expression may not be evaluated if the results can be determined by evaluating only the first operand. This can lead to more efficient code, especially in situations where evaluating the second operand could have side effects or be unnecessary. As you can see in the below screenshot, in a logical AND expression, if the left operand is false, the overall result is guaranteed to be false, so the right operand is not evaluated. Let's now try this out in IntelliJ. Let's now discuss about the comments in Java. At line number 3, we are showcasing the single line comment, which, as the name suggests, is only one line long. It is represented by double forward slash. Then, from line number 7 to line number 10, we are using the multi-line comment, which again, as the name suggests, is used to write multiple lines of comment. It is represented by opening forward slash asterisk and then closing asterisk forward slash. From line number 15 to line number 22, we have what is called as documentation comment. Documentation comments are a special type of comments used to generate documentation automatically. They begin with forward slash asterisk asterisk and end with asterisk forward slash. They are often placed before classes, methods, and fields. They are highly used in production environment. Java doc comments can include special tags like @param, @return, @throws, etc. to provide additional information for generating documentation. As we can see here, it has @param and @return in it, which represents the input variables that it takes, that is A and B, and what it returns, that is the sum of A plus B. For demonstrating the concept of short-circuiting Java, we'll use the following example. In this example, we have defined another function named showAllMessages, whose only job is to output a single line, that is hello world, in console output screen, and then return true. Now at line number 3, we have defined an expression which is false and showAllMessage. Now, as we already know that in AND operator, if any one of the input operands is false, then the final result will always be false. That is why when compiler evaluates this expression, it goes from left to right and then first sees false as the left hand side of AND operator. Then it would know that whatever is there in the right hand side of the AND operator, it doesn't matter. It would always come out as false. That is why it would never calculate that expression. Let's try to see this in action. Let's now run this program. And here we have the output as false. But now, if we change the position of the custom function in the expression and write showAllMessage and false, and then run this program, it would show us hello world and then false. Now why is this happening? As we have already mentioned, that compiler evaluates this expression from left to right. First, it checks the showAllMessages function, where it receives true as the output. And then it has to check the other side of the AND operator to see if the final result would be a true or false. Now this is a very important question from the perspective of an interview, as a lot of people don't know about this. As always, we'll end this video with a quote which says, "The future belongs to those who believe in the beauty of their dreams." Thank you for watching and have a great day.